This is a day in the life, part of a series of videos showcasing the amazing diversity of health-related jobs. In these interviews, we'll hear a little bit about what a day in the life of a health professional may look like. If you are interested in science, technology, engineering, and math, the STEM careers are very important to consider. STEM careers are able to integrate cutting-edge work and apply it to important health-related discoveries, from understanding the most basic functionality of things to creating new technologies, diagnostic tests, or therapeutics to improve health.
My name's Teresa Woodruff, and I'm the Vice Chair for Research in the Department of Obstetrics and Gynecology at Northwestern University Feinberg School of Medicine. My graduate students are part of a program called the Oncofertility Program. So that's a new word in the English language, and in fact it's a word that I coined about 8 years ago. What I recognized is that there were many more young cancer patients who were surviving their disease, largely because over the last 30 years, basic science has had an amazing impact on cancer survivorship. And we were thinking about males along the way. Lance Armstrong's a great example of that, who in his case, he was diagnosed with a broadly metastatic disease. And that means that his cancer was already at a number of different organs, his lung, his liver, his brain. But even though he had that very devastating diagnosis, he was told to go bank his sperm. But at the time, no women were being offered that same option. They had the same hope for survival in the future, but not with the same fertility outcomes. Studying how the ovary works is what my lab is interested in. Women are born with all the eggs they'll ever have. They sit in the ovary, about 1 million of them. From birth to menopause, those 1 million follicles begin to grow and develop. Some go on and ovulate, but the vast majority of them actually die. And what we don't understand is why one follicle would begin the process leading to ovulation, the release of an egg, when a woman is 19 and it's May, and one sitting right next to it doesn't begin that process for 10 or 20 or 30 more years. This is a great problem in biology. And so we've been studying how those follicles make decisions at different times during a woman's life. And in the process of studying that kind of pathway, we developed a way to take the follicles out of the ovary and put them in a laboratory dish and be able to grow those completely in the laboratory. That led us to be able to test those eggs, and the eggs could be fertilized, and that gave rise to live, healthy baby mice, the first two of which we named NU born, Northwestern University born, NU age. We had knew this and knew that, and then my lab said I couldn't name any more mice. For about 10% of adults and all of the pediatric, the children, the little girls who are going to have a cancer diagnosis, have a sterilizing cancer treatment but are going to survive their disease, what we can do for them is remove one ovary prior to that first sterilizing treatment. We isolate those immature ovaries just like we did to make newborn and new age, and we can now grow those in culture. And one day we hope to test the human eggs, and hopefully that will give rise to a healthy child for a cancer patient for whom cancer is in the long rear view mirror, but now this is the fertility that they always hope for in the future. So one of the other things that I run is the Women's Health Research Institute at Northwestern. And just as I'm passionate at creating new opportunities for young women who didn't have a fertility option before the Oncofertility Program was created, I'm really passionate about ensuring that there is sex parity in basic science and in clinical medicine. I think we should never lock the doors to anyone who wants to walk in and just see what it is that we do. What we want to do is open up and demystify what a laboratory is, and we bring young women from all across the city of Chicago into our laboratory, and we introduce them to basic scientific principles, how to ask questions and how to solve problems. That's been a very exciting part of our program. We've had several hundred young women do this, come into the laboratory, and then go on to college and to careers in science and medicine. And I think that's where we want to continue to influence a whole generation of new thinkers so that they are not intimidated by walking into a laboratory. I tell the young women who come in, always step up, be at the front of the class, step up to the bench. Someone else might try to angle you out, but you be the one who stands up at the front, and that's going to take you places that maybe you can't even imagine today.